If your application went down last month and users were still hitting dead servers for 5 minutes, you probably misconfigured your DNS TTL in Traffic Manager, and I'm going to show you exactly how to fix that in the next 8 minutes.
Hey everyone, welcome back to the Network Ninja Cloudcast. I'm Alex, and I'm here with our resident cloud expert ready to dive into Azure Traffic Manager today.
Thanks, Alex. Today we're breaking down exactly how Traffic Manager routes traffic using DNS and how it knows when your endpoints are actually healthy. This is the stuff that keeps your apps running when things go wrong.
So I've been confused about Traffic Manager because it's called a load balancer, but it doesn't actually touch the traffic, right? How does that even work?
Perfect question, and this trips up so many people. Traffic Manager is a DNS-based traffic router, not a traditional load balancer. Think of it like a really smart phone directory. When someone calls asking for pizza delivery, the directory doesn't deliver the pizza. It just tells you which pizza shop to call based on criteria like which one is closest or which one is actually open right now.
Oh, so when a user types in my app's URL, Traffic Manager just tells their browser which server IP to connect to?
Exactly right. Here's the technical flow. In production, you'll have your custom domain like www.conteso.com with a CNAME record pointing to your profile.trafficmanager.net. So when your user's browser asks its DNS resolver for www.conteso.com, that CNAME redirects the query to Traffic Manager's DNS servers. Traffic Manager looks at its routing method, whether that's performance, priority, weighted, geographic, or multi-value, checks which endpoints are healthy, and returns the appropriate endpoint's DNS name or IP address. The user's browser then connects directly to that endpoint. Traffic Manager never sees the actual HTTP request or response.
Wait, so if Traffic Manager picks a server and that server goes down right after, the user is stuck hitting a dead server until the DNS expires?
And this is the critical piece most people get wrong. Traffic Manager returns DNS responses with a configurable TTL, and the default is 60 seconds. But here's what happens in practice. The user's browser caches that DNS response. Their operating system might cache it, their corporate DNS server caches it, their ISP's resolver caches it. So even if you set TTL to 60 seconds, some of those intermediate caches might hold on to it longer.
So what's the right TTL to set? Should I just make it really short, like 10 seconds?
There's a real trade-off here. Shorter TTL means faster failover, but it also means more DNS queries hitting Traffic Manager and more latency for users because they're doing DNS lookups more often. For most production workloads, I recommend 30 to 60 seconds. If you're running something ultra-critical where every second of downtime matters, you can go as low as 10 seconds, but you'll pay for it in DNS query volume. The setting is in the Traffic Manager profile under Configuration. It's called DNS Time to Live.
Okay, so how does Traffic Manager actually know if an endpoint is healthy? Is it pinging the servers?
Traffic Manager uses active health probes, and this is where it gets interesting. You configure a probing protocol, either HTTP, HTTPS, or TCP. For HTTP and HTTPS, you specify a path like /health or API/status. Here's something important to understand. Traffic Manager sends probes from multiple Azure locations simultaneously, typically 3 to 5 different geographic locations. Each of those locations sends requests to your health path every 30 seconds by default. So your endpoint actually receives multiple health check requests per interval, not just one. If the endpoint returns any status code in the 200 to 299 range within the timeout period, it's considered healthy. You can also configure custom expected status code ranges if your application uses different codes. Anything outside the expected range marks it as degraded.
So I need to actually build a health endpoint in my application?
Absolutely, and this is where I see the biggest mistakes. Don't just return 200 OK from a static page. Your health endpoint should actually verify your app can do its job. Can it connect to the database? Can it reach the cache? Can it write to storage? If any critical dependency is down, return a 503. I've seen teams point their health probe at their homepage, and the homepage loads fine from static cache while the database is completely dead. Users get routed to a server that looks healthy but can't actually process requests.
That's a really good point. What happens if the health check fails? How fast does Traffic Manager react?
Here's the math, and it's a bit more nuanced than people realize. The default probe interval is 30 seconds, and the default tolerated number of failures is 3. But remember, probes come from multiple global locations simultaneously, and Traffic Manager aggregates results across these probing agents to determine endpoint health. It's not just sequential failures from a single source. Now, if you need faster failover, you can enable fast endpoint monitoring, which is a premium feature that allows 10-second probe intervals instead of the standard 30-second minimum. With fast probing enabled, you can set tolerated failures to 1 or 2 and get detection down to around 10 to 20 seconds. But remember, even after Traffic Manager marks the endpoint unhealthy, you still have that DNS TTL we talked about. Users with cached DNS responses will keep hitting the dead endpoint until their cache expires.
So total failover time is really detection time plus DNS TTL?
Exactly. If you want sub-minute failover, you need to enable fast endpoint monitoring with a 10-second probe interval, set tolerated failures to 1 or 2, and keep TTL at 30 seconds or less. But test this in your environment first because aggressive probing from multiple locations can add load to your endpoints, and fast probing has cost implications you should review.
What about the different routing methods? When would I use performance versus priority?
Priority is your classic active-passive setup. You have a primary endpoint with priority 1, secondary with priority 2. All traffic goes to primary until it fails, then Traffic Manager returns the secondary. Great for disaster recovery. Performance routing is smarter, but it works differently than people assume. Traffic Manager doesn't continuously measure latency to your specific endpoints in real time. Instead, Microsoft maintains what's called an Internet Latency Table that maps DNS resolver IP ranges to Azure regions based on network latency measurements they've collected. When a DNS query comes in, Traffic Manager looks up the resolver's IP range in this table and returns the endpoint in the region with the lowest latency for that resolver's location. This is what you want for global applications where you have deployments in multiple regions.
Let me make sure I've got this. Traffic Manager is DNS only. It never touches actual traffic. It uses health probes from multiple Azure locations to check endpoints, and the total failover time depends on both probe settings and DNS TTL. Fast probing gets me quicker detection, but it's a premium feature, and I should build real health endpoints that check my dependencies, not just return any 2xx status from a static page.
Perfect summary. One last pro tip. Enable Traffic Manager diagnostic logs in Azure Monitor. You can see every health probe result and every DNS query. When something goes wrong at 3 a.m., those logs are gold. Go into your Traffic Manager profile, click Diagnostic Settings, and send logs to a Log Analytics workspace.
This is super helpful. I'm definitely going to check my health endpoint configuration today.
That's it for today's episode. If you found this helpful, please hit that like button and subscribe to the channel. We've got more Azure networking deep dives coming.
And share this with anyone running multi-region applications. This stuff matters when things break.
Thanks for watching the Network Ninja Cloudcast. See you in the next one.